Hello and welcome to another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 1, Lesson 5 on fractions and decimals. One of the major focuses of Math 7 is the tie between quantities that are represented by fractions and quantities that are represented by decimals. Because the plain fact is, fractions and decimals, whether you like them or don't like them, are just a way of measuring how much of something we have, right? And because of that, every fraction can be written as a decimal, and every decimal can be written as a fraction. And we want to get some ideas on how to do that conversion back and forth. And this lesson is going to get at those. So let's jump right into it for Lesson 5. Here we go. Let's do some basic decimal review, right? Because decimals are fractions, and in exercise 1, we're going to take a look at that. Let's do it. For each of the following decimals, write it in fraction form and then reduce it to simplest form. In other words, simplify it. So let's do this. Now it's simple enough, right? The idea here is that 0.2, right, which is 2/10, is a fraction, right? This is a fraction. It is the fraction 2/10, which, when simplified, would be the fraction 1/5, right? We can just divide both the numerator and the denominator by 2, and we get 1/5. And again, I can't emphasize this enough, right? 0.2 and the number 1/5, or the fraction 1/5, are the same number, right? If I said I had a fifth of a pizza, or if I had 0.2 pizzas, sounds a little weird, but whatever, then I would have the same amount. All right. Each one of these, letter B, letter C, and letter D, each one of these decimals can then be written as a fraction, which sometimes can be simplified and sometimes it can't. In fact, let's do letter B together. It's one of the most famous decimals of all, 0.75. Now, a lot of times people will literally read this as 75 hundredths, right? And when we have two decimal places, we can literally rewrite this with a denominator of 100. Now, 75 divided by 100, or 75 hundredths, we can divide both numerator and denominator of this fraction by 25, and that will give us the common fraction 3/4. So 0.75 and 3/4 are the same number. They're the same quantity. I'd like you now to pause the video and do the same thing to letter C and letter D. All right, so in letter C, right, 0.32 is the same as 32 100ths. Both 32 and 100 are divisible by 4. 32 divided by 4 is 8. 100 divided by 4 is 25. So 0.32 is the same as the fraction 8/25. In letter D, we have 55 hundredths, right? Now there's not much we can do, but we can divide both the numerator and the denominator by 5 to simplify it. 55 divided by 5 is 11, and 100 divided by 5 is 20. And again, I just can't emphasize it enough. These are just different ways of representing the same quantity, all right? And so it's pretty easy to see how we can take a decimal and change it into a fraction. Now, the other way around, taking a fraction and changing it into a decimal, that's a little more challenging. And we're going to start to take a look at it in the next exercise. All right, converting a fraction into a decimal. Exercise number 2. Consider the fraction 1/4. We will convert it to a decimal in two different ways. Letter A asks us to convert this fraction into a decimal by rewriting it with a denominator equal to 100. All right, so let's do that, right? I mean, this kind of makes sense to do it this way, given that all decimals are fractions with denominators of 10, 100, 1,000, 10,000, etc. So we can take 1/4, rewrite it as an equivalent fraction with a denominator of 100 by multiplying both the numerator and denominator by 25. That will give us the equivalent fraction 25 100ths. But now 25 100ths is just 0.25. All right, keep in mind, we can always create two equivalent fractions, meaning fractions that are the same amount, by multiplying the top and the bottom of the fraction by any number that we want, except for 0. We can also do it by dividing the top and bottom by any number we want, except for 0. No adding or subtracting, but multiply or divide the top and the bottom by anything you want, and you get a fraction that's equivalent. But now, let's look at what our focus of today is going to be, which is how we can change a fraction into a decimal using division. Right? Now, this is key. The fraction 1/4, and we've talked about this, is the same thing as 1 divided by 4. Now, this can be kind of confusing because we typically think of taking a larger number and dividing it by a smaller number. But I can have something like the number 1 divided into 4 equal parts. If I had 1 pizza and I divided it into 4 equal parts, each person would get 1/4 of a pizza, right? So we can take a smaller number and divide it by a larger number. But since we now know how to divide using decimals, we can now do this particular problem. So let's do that together. Let's do 1 divided by 4. Now, in order to do that, I actually had to add a couple extra decimals. Now, remember with decimal division, I'm just going to move this decimal point up here. All right, I'm going to say how many times is 10 divisible by 4? That's going to be 2. 2 times 4 is 8. When I subtract, 10 minus 8 is 2. I bring down my 0 and I get 20. Now, how many times does 4 go into 20? That's 5 times. 5 times 4 is 20. And when I subtract, I get 0. And that's what I really want. And look at that. 0.25. Oftentimes when decimals are smaller than the number 1, many times people will put a 0 out front. They'll say 0.25, right? But this is essentially how we can convert a fraction into a decimal. All we have to do is divide the numerator by the denominator, all right, and use our decimal division that we already know how to do. So let's get some more practice with this. Very important to be able to convert fractions into decimals, and also just to know some common decimals. We want to know that 1/4 and 0.25 are the same number. And you probably do, because many times you call this 1/4, and many times when you see this, you know in terms of dollars and cents that that's 1/4, right? So let's keep moving on. Exercise number 3. Convert each of the following fractions into decimals using long division. Each decimal will terminate. Okay, we're going to see in a little bit decimals that don't terminate. They're some of the coolest things in mathematics. I mean, seriously, some of the coolest stuff. But let's take a look at, again, another one of these that we do together, and then we'll have you do a couple of them on your own to see what the decimal version is of each of these very common fractions. So let's start with 4/5. Now, remember, what 4/5 is literally the number 4 divided by the number 5. And so down here, we're going to have 4 divided by 5, and we're going to have to put in a 0.0. Maybe we're going to need more zeros. I don't know. But now we say, all right, we put that decimal place up here. Maybe we'll put a 0 out front. 5 goes into 40 8 times, and we get 40. And we subtract and get a remainder of 0. And that's actually all I needed. I mean, I could keep doing more and more of this, but it's 0.8, right? We have a remainder of 0. Anything else that I put on here would just be 0.8, 0.0000, etc. And there's no reason to do that. All right, let's do one more together and then have you do letter C on your own. Let's do 3/4. And again, you're probably already very aware of what decimal 3/4 corresponds to, but it's kind of cool to see it in this process. So let's do it, right? 3/4 is just the number 3 divided by the number 4. So when I do that, I can put my 0 right here. I can say, okay, how many times does 4 go into 30? That's going to be 7 times. All right, that's going to leave me with 28. When I do the subtraction this time, I have a remainder of 2. So I have to drop another 0 down. Now, how many times does 4 go into 20? That's 5 times. I get 20, I do a subtraction, and I get a remainder of 0. 0.75. 3/4 and 0.75 are the same thing. And again, you know that. You know, literally, if I had 3/4 and I said, how many cents do you have? You'd say 75 cents, right? 75 1/100ths. Pause the video now and do letter C on your own. All right, let's do it. 7/8, or 7 divided by 8. I don't know what that weird symbol was. It's like 7Z. How about, there we go. All right, so we're gonna have 7 divided by 8. I'm gonna have to put a 0 here. How many times does 8 go into 70? Well, that's gonna be 8 times. It's gonna give us 64. When I do the subtraction, I'll get a 6. So I have to drop another 0 down. How many 8 times does 8 go into 60? This is gonna be just 7 times this time. That's gonna give me 56. I do a subtraction, I get 4, drop another 0. How many times does 8 go into 40? That's 5 times. And I run into the eMathInstruction symbol, subtract, and I get 0. So 7/8 is the same as 0.875. All right, pretty easy to do this. We just have to keep in mind, right, that we're gonna get decimals that are less than 1. It's a little bit weird that we have a number under here that's smaller than this number, but again, we're in Math 7 at this point, right? So we should be able to do this and convert any fraction into its equivalent decimal. But sometimes that can be a little bit more tricky than other times. So let's look at a process where this doesn't terminate in a remainder of 0, but where this process actually continues forever. All right, let's take a look. Repeating and never-ending decimals. Repeating and never-ending decimals. Some fractions have decimal forms that never end, but repeat some type of pattern, right? So let's take a look at what exercise 4 asks us. Each of the following fraction converts to a decimal that eventually repeats itself. Use long division to convert each fraction to its decimal form, and use the repeating decimal bar to show the portion of the decimal that repeats. All right, so let's do this. 1/9. All right, so 1/9 is simply the same as 1 divided by 9, right? And so that's going to be like this. Now, I'm going to put a 0.0 here, and maybe some more zeros. All right, and I say, how many times does 9 go into 10? Well, that's 1 time. And then I subtract, and I get a remainder of 1, and I drop a 0 down. And I say, how many times does 9 go into 10? And that's 1 time. And I get a 9, and I subtract, and I get a 1, and I drop a 0, and I get a 10. And I said, how many times does 9 go into 10? I get 1, right? And I mean, unless, I really want to beat my head against the wall, right? What I notice here is that I'm just going to keep doing that again and again and again, right? No matter how many times I do it, I'm going to get 10 minus 9, I'm going to have a 1, I'm going to drop a 0 down, I'm going to keep going. So in fact, this would just end up being 1s, well, until the end of time, quite frankly. So what I can do is, because the 1 just repeats forever, I put a little bar over the first 1, indicating that that part of the decimal repeats forever. All right, and in fact, 1/9 then is 0.1 with a bar over it. All right, I don't put a bar over the 0, it doesn't repeat, it just sits there, right? So sometimes you'll get decimal expansions where there's a portion of it that doesn't repeat, and then there's a portion that repeats forever. Let's do 2/3 together, okay? So 2/3 is going to be 2 divided by 3. Well, let's do that. 2 divided by 3. All right, I'm going to put a 0.0, maybe a couple of zeros here. All right, how many times does 3 go into 20? 6 times. I put down an 18, I subtract, and I get 2. I drop down a 0, and I have that 20 again. How many times does 3 go into 20? 6 times. I get 18, etc., right? This is just going to keep going. I don't need to do this very long. I just have to wait until I start to see the pattern repeat, right? So in fact, 2/3 is the same as 0.6 with that 6 repeating forever. 2/3 and 0.6 with the 6 going on forever. 0.666666666 all the way out forever is the same as the fraction 2/3. Let's do one more together and then have you do a few on your own. Actually, I take it back. Let's pause the video now. You try letter C, see what you get, and then we'll continue to do some together. All right, let's take a look at 5/6. Right, 5/6 is simply 5 divided by 6. All right, 5 divided by 6. So that's going to be 5.000. I'll just kind of extend it out here. All right, how many times does 6 go into 50? Well, let's see, I think that's 8 times, right? Because 8 times 6 is 48. And then I'll get a 2. I'll drop a 0 down. How many times does 6 go into 20? That's a 3. Right, that's going to be 18. Subtract. I'll get 2. Drop the 0. That's going to be 3. 18. Subtract 2. Drop the 0, etc. Now, let's talk about this a little bit. Like 1/9 is 0.1 with the 0.1 repeating. 2/3 is 0.6 with the 6 repeating. 5/6 on the other hand is 0.833333333. The 8 is not repeating, right? Only the 3 is. So I would say that 5/6 is equal to 0.83, and then I would only put the repeating decimal bar above the 3, not above the 8, because the 8 only showed up once. All right, let's keep going. We've got some more practice on these. 5/11ths, 11/15ths, and 7/12ths. Now, of course, it gets harder when the denominators get larger just because the division gets harder, okay? What I'd like you to do now is pause the video, work through letters D, E, and F on your own, all right? And then we'll come back and we'll take a look at them. All right, I love 11ths. 11ths, 9ths, they're all kind of fun. So 5/11ths is going to be 5 divided by 11. So let's do it. 5 divided by 11. Okay, and to get ready for all this repetition, I'm going to put some zeros out here. All right, how many times does 11 go into 50? That's going to be 4 times, right? That's going to give me 44. When I do my subtraction, I'm going to get 60. How many times does 11 go into 60? That's going to be 5 times. That's going to give me 55. I'm going to subtract. I'm going to get 5. I'm going to have 50. How many times does 11 go into 50? That's 4 times. That's going to give me 44, right? I'm going to subtract. I'm going to get a 6. I'm going to drop a 0, get 60. How many times does 11 go into 60? That's going to be 5 times. That's going to be 55. Subtract. Oh man, I see it. I see the pattern, right? Etc. Right? This one, 0.4545454545, right? This time it's a 2-digit pattern that's repeating, which is kind of cool. So 5/11ths is the same as 0.45 with both of those repeating. All right. Whoops. Yeah, that didn't really quite come out right. There we go. Great. With both the 4 and the 5 repeating. Let's do 11/15ths together. Ooh, give myself a little bit of space here, move that away. So this is going to be 11 divided by 15. All right, here we go. 11 divided by 15. Give myself some zeros to work. All right, how many times does 15 go into 110? All right, well, let's try 7, right? 7 times 5 is 35. 7 times 1 is 7, plus 3 gives me 10. Ah, that looks right. So when I subtract, I'm going to be just left with 5. So now I'll have 50. How many times does 15 go into 50? That's going to be 3 times. Let me get rid of this. 3 times 15 is 45. When I subtract, I'm going to have 5 with another 0. So that's 50. That's going to be 3 times 45. Ah, and now I have that repetition. Right, you know you've got that repetition when you kind of see something like this going on, right? When you suddenly see things up here repeating. So 11/15ths is the same as 0.73, but only that 3 is repeating, not the 7. All right, let's now do 7/12ths. All right, that's going to be 7 divided by 12. All right, here we go. Get me some zeros. Probably won't need them all. How many times does 12 go into 70? Well, let's try that 5 times, right? So 5 times 12 is 60. Hopefully we know that. When we subtract, we get 10, and we drop another 0 for 100. How many times does 12 go into 100? Well, that one's a little bit trickier, right? But let's try what? 8? 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9. Ah, I like it, 96, great. Subtract, I'll get 40. How many times does 12 go into 40? Let's do 3. 3 times 12, get rid of that 1, is 36. When I subtract here, I get 4. Drop the 0, 40, look at that, there it is. 3 times 12, 36, and we get our repetition going on. And again, look at that 0.3 repeated. So this one's going to be 0.583 with only the 3 repeating. It's kind of cool. There can be portions of the decimal version of a fraction that don't repeat, like 0.58, and then 0.333333, etc. Now all of these started to repeat after a certain amount of time. And one cool thing about fractions is that every fraction will either have a decimal that just terminates because eventually the remainder is 0, or it repeats in some type of pattern. The problem is some fractions take a lot longer than others. Let's take a look at the curious case of sevenths. All right, exercise number 5. Fractions with denominators equal to 7 often take a long time to repeat. Convert each of the following fractions into decimals. All right, so like some denominators are nice. Like 4 is a nice denominator. 2 is awesome. I don't mind 8 so much. 10 is the best, okay? Things like 3 get a bit annoying, 6, 9, 11, but 7, oh, 7's the worst, but also kind of cool. Let's convert 1/7 together to a repeating decimal, and then have you convert 4/7 on your own. I'm going to move this away. Let's do it. 1/7, right? That's the same as 1 divided by 7. So let's take a look at what that's going to be down here. Now it's going to take a little while to repeat, so I'm going to give myself a lot of zeros. All right, here we go. How many times does 7 go into 10? Well, that's 1 time, right? So when I subtract 7 from 10, I'm going to be left with a 3, drop the 0. 7 goes into 30 4 times. That's going to be 28. And when I do the subtraction, I'm going to get a 2. I'm going to drop a 0. 7 goes into 20 2 times. I almost said 3 times, but that would be incorrect. That's going to be 14. When I subtract, I'm going to be left with 6. Drop a 0. 60. How many times does 7 go into 60? That's going to be 8 times, right? That's going to be 56. Subtract, I'm going to have to move my board up. Look at that. That's how much room I need. Subtract, I get a 4. Still no repetition. Drop 0. How many times does 7 go into 40? That's going to be 5 times, which is 35. Subtract, I get a 5. Still no repetition. Drop the 0. How many times does 7 go into 50? That's going to be 7 times. It's going to be 49. Subtract, and I get a 1. Now, why is that important? Well, the 1 is really important because that's where I started, right? I started with a 10, and maybe it would be easier to see, right, when I drop that extra 0. I now am back to where I started with, 10, and how many times 7 goes into 10? And that will be 1 time, right? So what would happen now is if I kept going, I would get 1, 4, 2, 8, 5, 7. Then I'd get 1, 4, 8, 2, 8, 5, 7. So the remarkable part of this is that it takes all of this before we start to repeat again, right? So, in fact, 1/7 is the decimal 0.142857 with all of that repeating itself again and again and again. All right, anything with a denominator of 7 other than 7 divided by 7 is going to be kind of ugly, well, or any multiple of 7. So why don't you go ahead and try to convert 4/7 into a decimal. Watch for it to take about this long to repeat. All right, let's go through it. Let me get this out of the way. 4/7 is the same as 4 divided by 7. All right, so, and give myself a little more room than that. 7 goes into 4. We'll put a bunch of zeros. All right, 7 goes into 40. That's going to be 5 times. So we'll get 35. Subtract 5, 0. 7 goes into 50 7 times. 49. Subtract 1, 0. 7 goes into 10 1 time. Subtract 3, 0. 7 goes into 30 4 times. 28. Subtract 2, 0. 7 goes into 20 2 times. 14. Move it up a little bit. Subtract. Get a 6. 0. Still not repeating. 7 goes into 60 8 times. Gives me 56. Subtract. And I get 4, 0. And that's where we start to repeat, right? 40 and 40. So this is going to be the repeating portion of the decimal. 0.571428 with all of that repeating. If you need to see the repetition, keep going on, right? Keep doing it. And again, you'd get 0.571428, 571428, 571428, etc. This is something that even a calculator can't really show you because eventually the digits on a calculator do what's called terminate. They got to cut off because the screen's only so long, right? Eventually they just got to stop. And we'll look at that in a future lesson where we do use the calculator. Let's wrap it up for now. All right. So today, what we were concentrating on was moving back and forth between decimals and fractions, mostly from fraction to decimal by using long division, but also a little bit from decimal to fraction by just recognizing the fact that decimals are just fractions. That's all they are, with denominators of 10, 100, etc. All right, this is a huge connection in this course and really in mathematics in general. You know, you just generally want to know, oh, 1/3 is 0.3 repeated. You know, 1/2 is 0.5. 3/4 is 0.75. There's a lot of times in real life where you want to know the decimal version of a fraction, and if you have to, you know, you could produce it by doing this kind of division. All right, we'll use this a lot more in future lessons. For now, though, I just want to thank you for joining me for another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.